voltage from the receiver to the processor in the ground station, which requires more than 3.3 volts. This circuit will be integrated into the new boxes. So what you'll end up getting is just a cable with 2 male ends. Okay, cut.
Rolling.
Okay. This is the assembly of the 3 parts. You screw the antenna onto the SMA port. You plug in the cable to the other end, and just to show you what the ends look like, this one says RC. Alright, well, let's see. So here's a current sensor in the airplane, and it obviously comes out where the battery would connect to the speed control. And then the ribbon cable is generally along the bottom under the battery pack. See it there? Okay, there you go. And the transmitter is obviously in the back there, and
Back in this location.
about there, and show where the antenna would come out.
We'll just pull it out.
Okay, so there's the antenna.
It's taped to the coax is taped to the fuselage, and the last portion of it's allowed just to
fly in the breeze.
fly in the breeze.
So because it's a 430 megahertz, it's obviously a lot longer than a 2.4 gigahertz antenna. So it's about 7 inches long or so. And now she's out. Okay, so this is actually node ID 32. So if you were clever, you notice I changed the ground display to 32 because this is the one we wanted to run some amps through. So there you go. And to put it in, I guess you use a little fish tape or something to be able to.
A piece of plastic tubing like I have over here.
Yeah, a piece of plastic tubing to basically to connect the hole to there. So you're gonna have to plan on putting a hole in your airplane. Unfortunately, the internal antenna was not reliable in a carbon fuselage. So you might say, well, what it works in the airplane for flying? Well, that's only received.
Well, nobody put,
Yeah.
you put your 2.4 on the outside of the airplane for the same reason.
True. Yeah, your 2.4 outside airplane for the same reason. We tried it without it with an internal antenna. It was not reliable. The range is much better this way. Okay. All right, this is how we install the device. So we've taken this small bit of a thin yellow tubing and we put it in the hole in the fuselage and push it in through to the wing opening. And now Steve's going to connect it to the end of the antenna. And basically use it as a guide to push it in so that it eventually comes out of the same hole. And there it is. Okay, so it's now connected, or it's now in the hole. Now we put a piece of tape to hold it secure to the fuselage, the coax part, and we allow the actual antenna part to dangle, and there it is. So inside the fuselage we see nothing because it's back there, and
Back in this position.
and then if you were doing this the first time, then you would probably, using little bits of tape, you want to tie the flat ribbon cable at the bottom of the fuselage with a spot of tape here and there so it doesn't interfere with your batteries. And then of course it connects to your to the current sensor. And when you install it, you have to just connect the this goes to the negative most balance port of the battery, and this goes in series with the positive battery leads. So hopefully you'll need. Our standard polarity is we put the female barrel on the battery and the male on the battery plus. Hence, you'll notice the polarity is indicating positive here. We realize a few people have reverse polarity, and probably have to make some adapters to do that for you. Okay.
Okay.
All right, now we've connected the gas box to the ground station, and we also connected the spare receiver to the unit, and we'll now power it up. So briefly you saw the firmware revision, and now it's going to ask you to enter the node IDs of the airborne system. So you see we have 120 here we're going to connect it to. So I'm going to just I'm going to go use the up key to put a 1 in there. I'm going to go over there to make this go up twice to make it a 2, and now I've matched the numbers, so I say enter. Okay, now it's going to want the node ID of the backup model. In this case, we don't have one, so we're just going to hit enter to store the backup node ID as the same as the primary node ID. Okay. So now the device is going to adjust the channel of the receiver to match the airborne unit. And it's now looking for the pulse width of the receiver. That's going to eventually end up talking to the gas box. Okay, cut.
Transmitter is on.
Okay.
Or camera is on.
All right. All right. Now we've turned on the transmitter, and it's got a bound. This will be the secondary receiver. As you can see, the throttle is normally low, and it's about 1,000 microseconds, so that's normal. So I'm going to say enter, which is going to store the low value. Okay, and then it's going to ask for the high value. Now I toggle the throttle to high, and eventually it's going to go up to the full value. And while its throttle is high, I'm going to hit enter, which is going to store that. Okay, and now essentially those values become related to the gas sensor. So right now, you notice how gas sensor cal is going to change between low and high. So when it's low, I hit the side button on the gas box like usual, and then when it's high, I'm going to wait again. It's a little sloppy there. Okay, and there's the high value. So now I hit enter again, and I'm now ready to operate. So this is the operating. You'll see it node ID appears there for both primary and backup. And channel 4 is the RF channel that goes along with node ID 120. And right now the RC is 0 because it's off. Now if I toggle the throttle to high, you'll see that jump to 1. So this basically would be the RC input to the system. And you notice the gas box jumps to 82, which would be the equivalent of motor on when the throttle's on, even though there's no RF input. You see the RF is N for null, meaning there's no RF because the airborne unit is not on yet. So if worst came to worst, you could fly like this without this functional, and it would work exactly like the previous system. Okay, cut. Outside with the model, and we're gonna do first a test blip, and we're gonna show that the display should revert to 000 RF. Go ahead. Okay, here's a display, and that was a test blip, and now they're showing, it says watt minutes as 000, and the RF is still null because it's no longer transmitting once the motor's off, but once we start flying, it'll transmit regularly, and then the null will turn to a 0 or 1 if you're watching it while the motor's running.
You want me to turn the motor on?
Yeah. Okay, now we're doing, yep. Another. Okay, you probably heard that. The motor was on, RF went to 1, and it's now back to null. It stopped transmitting. The watt minute is 0 because it's less than 50 watt minutes. This is only a 5-cell battery. Okay,
Run longer?
Yeah, longer. Let's get some real watt minutes. Okay, and now we have 131 watt minutes. So that's generally the first climb is about 225, and it's about 100 after that. So ideally, you want to finish your distance at about 1,500, leave you 200 for duration. So, okay, so why don't you do one more longish climb? Okay, so as you can see, the RF went to 0 immediately. Now the watt minutes is 210. So that's how it works. So generally, your pilot will want to know maybe every third or fourth climb how he's doing. And you probably want to make yourself a little chart to kind of learn to pace yourself. It's generally about 225 for the first climb, and maybe about 100, 110 for a 4-leg climb, maybe a little bit higher for a 6-leg climb. So again, your pilot's going to be overwhelmed, and probably he's going to only want to know after the second or third climb how he's doing. Okay, that's it. We'll see you in Lugo.